All right, lesson 1.2.2. So we've been looking a lot at inputs and outputs, and we call that just kind of a relationship. Like there's a relationship between the input and a relationship between the output. And sometimes we've been using the word function. But today what we're going to see is that every single relationship, input and output, is not necessarily going to be a function. So we wanted to define exactly what makes a relationship a function. All right, so we're going to look at it as, to start this, we're going to look at it like if you had like a soda machine or something like that. So this particular soda machine, it's got some buttons. The first two say blast, blast. And then we've got a slurp. Gosh, I can't even read that. Lemon twister and diet slurp. All right, so we've got several different things, several different buttons here. So when we're looking at inputs, we could think of it as a couple things. Maybe the inputs are those buttons that you've got. So you've got a soda machine, and the inputs could be the buttons. Or, in order to buy the soda, you're going to have to pay some money. So maybe the inputs would be the coins that you pay to put into the soda machine. Okay, the output. I guess you could do even electricity, because you got to put electricity into the machine. I just saw this. But anyways, so those are all inputs. Output. So after you've put in your money, you press the button, hopefully the can of soda is going to come out of that machine. So a can of soda would be our output. All right, we got the machine, we're putting stuff in, buttons, coins, electricity. And we're getting stuff out. We're getting out cans of soda. We're going to focus on the buttons and then what's coming out as far as the can of soda. So let's say that we've got Miss Whitney. She goes over there. She's like super thirsty, and she likes like lemonade drinks and stuff. So she's like, okay, I want a lemon twister. So she goes up to the machine. She presses the button for lemon twister, and what comes out? Lemon twister. So her input was to press the button for lemon twister. The output is she gets lemon twister, which you would hope that if you press the button, you get what you're looking for. All right, so later on, she's thirsty again. I don't know, maybe she had to run the mile or something. So she's thirsty, and she's like, oh, I need another one of those lemon twisters. So she goes, and she presses the lemon twister button. And then out the bottom of it, instead of lemon twister, she gets blast. Okay, probably not super happy about that. Now we have to ask ourselves, is that machine functioning consistently? Are there predictable results with when she does an action? Can she predict what's going to happen? In her case, this is not consistent. Sometimes when she pressed the button for lemon twister, she got lemon twister. The second time, she pressed the button for lemon twister and got blast. So this machine is not functioning, like it's designed to function. So it's not functioning predictably or consistently. So we would say that you can't predict what's going to come out, because when you selected lemon twister, sometimes it was lemon twister, sometimes it was not. Okay, next couple people come along, and Brandy comes in, and she's like, oh, I want a can of blast. So she presses the button for blast. She presses blast button, and she gets blast. All right, so then her friend, Miguel, walks along, and he's like, yeah, blast sounds pretty good. I think I'll have a blast too. So Miguel presses blast, and what do you know? Out comes a blast. So at this point, is the machine functioning consistently? Are they getting predictable results? So in this situation, Brandy's pressing blast and getting blast, and Miguel's pressing blast and getting blast. It is consistent because the same thing's happening each time. So we have predictable results here. All right, next situation. Lutfi comes along, and he's like, gotta have some slurp. So he's gonna press the button for slurp. All right, and then out comes lemon twister. Miss Whitney would probably be happy about that, but Lutfi does not like lemon twister, so probably not very happy. All right, so later, Taisha comes along, and she presses the slurp button as well. Waits a second. Here's that little, that little sound, and it comes out, at the bottom, the happy sound. So she presses that, and she gets a can of lemon twister. Two unhappy people. And then she sat around because she was kind of upset. She sat around the machine and watched other people come up, and they kept on hitting the slurp button, and they kept on getting lemon twisters. So you had a lot of unhappy people. Now we have to ask ourselves, they are pressing the slurp button and getting lemon twister, but is this consistent and is it predictable? And we would have to say, yes, it's predictable. Even though the machine isn't functioning how they thought it should, once they saw the pattern of pressing the slurp button and always getting lemon twister, we can see that there's predictable results. So that if Taisha came by again and pressed the slurp button, she would expect to get lemon twister instead. So even though it's not functioning as you think the machine should work, at least it's presenting consistent results. All right, so what we're looking at here is a function is where when you have an input, you get a consistent result, something that's predictable. Now, in the case of Brandy and Miguel, they pressed blast and they got blast, and everybody was happy. They were getting exactly what they want. In the case of Lutfi and Taisha, they were both pressing slurp and they got lemon twister. Not too happy about it, but at least it was predictable. Once they saw the pattern, they saw that they were getting it. So these would be functions because you have a predictable outcome. When you have an input, you know exactly what you're going to get as an output. Whereas Miss Whitney, she had inputs of lemon twister and lemon twister, but got two different outputs. You can't predict what's going to happen. It's complete randomness, and you never know what's going to come out in the end. So you can't predict it. So that would not be a function because you're getting inputs with different outputs. And in a function, our inputs and our outputs have to be predictable. And this is unpredictable. All right, so let's look at some other situations. All right, so we've got first situation here. We've got a button on a candy machine, kind of like the soda machine. They press the 1 button, and they got Sticks candy. Press the 1, got Sticks. 2 M&Ns. 4 M&Ns. 2 duds. 3 duds. All right, so we have to ask ourselves, are we getting predictable results? Well, what we really want to look at is the X values. Here's the 2 where I pressed 1. And I got Sticks both times. That's predictable. If I press 1, I'm going to get Sticks. When I press 4, I got M&Ns. When I press 3, I got duds. But here I've got 2 situations where I press 2. And the problem is I got 2 different results. So when you press a 2, who knows what's going to happen? It's helter-skelter. It's all over the place. You don't know what's going to happen. So is this a function? And we would say, not a function. Because pressing 2 does not give us a predictable result. It gives us 2 different results when we press 2. Now, it doesn't matter that when I pressed a 2 and I got M&Ns, and when I pressed a 4, I got M&Ns. That's okay, because, on the candy machine, sometimes several of the little rows have the same candy on it. So that's okay. 4 was predictable, M&Ns. It's the inputs giving us different outputs that makes it unpredictable. So button 2 is unpredictable. So that is not a function because you're not getting predictable output. All right, next one. Now we're getting away from buttons and just doing inputs and outputs. So let's say these are our inputs. 7 goes into the function and we get 6. -2 goes in the function, get -3. 0, 4, 4, 2, 9, 10, -3, -3, 6, 0. So is this a function? Is this relationship a function? Because the inputs are related to the outputs, but are they related in a way that it's predictable? And we would say yes, it's predictable, because look at up top. I've got 7, -2, 0, 4, 9, -3, 6. None of those inputs repeat. So if they don't repeat, I'm just getting one answer for each of those non-repeating inputs. So we would say it is a function. Each time I have an input, I'm getting an output that's predictable. Now, if the next line said 6, 2, it would stop being a function because we plugged in 6 at 2 different times and got 2 different answers. But right now, we've never plugged in more than one of the same. So this is a function. So for each x, for each input, there is one output. You don't want to have an input that has more than one output. That stops making a function. It's a broken machine. All right, next one. We've got all these different numbers. And again, we're going to be looking at our x values. Here's a 2, and here's a 2. Let's look at their results. When the input of 2 was here, we got a 9. When the input was 2 here, we got a -8. We've got the same input with a different output. It's kind of like a calculator, really. If I had a calculator here and I did 3 times 5, I would expect 15 to come out. Now, if the second time I used my calculator, I typed in 3 times 5 and I got 24, I'd say that this calculator is broken because it's not giving me predictable results. Well, that's what's happening here, right here. I'm plugging in something and getting a different result. It's like plugging something into a calculator twice and getting 2 different answers. It's unpredictable. It's not quite as useful as you would hope it'd be. So we would say not a function. Because when you plugged in an input of 2, you got 2 different outputs. All right. So what must be true in order for a relationship to be a function? So on your paper, you need to write what you think has to be true for a function or for a relationship in order for it to be a function. Okay, so I don't know how you've thought of it, but maybe you said something about for each input, there can only be one output. And that would make a lot of sense. Or you can say it backwards and say for there should only be one output for each input. And that's correct too. All right, now we've looked at tables. Remember, we're shifting between tables, graphs, equations, and situations. So right now we've been doing mostly tables. We did do a situation up here. Now we're going to look at graphs and see if we can tell if something's going to be a function just by looking at graphs. All right, so we saw what it looked like in a situation. We saw what it looked like in a table. Now we're going to see what functions look like in graphs. Now remember, every single thing in a graph is an x and a y. So this point over here looks like it's at -3, 1. So x would be -3, that's the input, and then the y would be 1. The next point here is at -2, 3. The next point here is at -1, -1. Then I've got a point here at 1, 1. I've got a point at 2, 3. And I've got a point at 3, -2. So we have to ask ourselves, for any of those x values, am I getting more than one y value? And I'm not. Just writing these down real quick, we can see that when we plug in -3, we get 1. When we plug in -2, we get 3. When we plug in -1, we get -1. When we plug in negative or positive 1, we get 1. When we plug in 2, we get 3. And when we plug in 3, we get negative 2. So our x's are not repeating, so we're not getting more than one y value. Now, you do notice that we're getting more than one y value for different x's, but that's okay, because think back to your calculator. If you typed in 3 times 2, you would get 6. But if you type in 1 times 6, you also get 6. Your calculator's not broken. You're just doing different inputs with the same output, and that's okay. It's not broken. What's broken is if you do 3 times 2 and get 6, and then 3 times 2 and get 5, because you're getting different outputs for the same input. The same outputs are okay as long as the input was different. So here we've got 3 and 3 for an output, but that's okay because the input was different. It's really the inputs that you have to look for that can't have the same inputs with a different output. So we would say, yes, this would be a function. So, function. Okay, next one. Now this is a line where it's all connected, it's continuous, whereas this one was a discrete function, so we could pick each individual point. This one's continuous. All the points are connected. And we have to ask ourselves, are there any points on here where the x value is giving us 2 different y values? And the answer is yes. Here at negative 2, if I go up here, I've got a point right there. That looks like positive 2. So negative 2, 2 is on the graph of that function. But then if I go down here, I don't know what number this is, but it looks like it's like negative 2, negative 3. So we're going to say this is not a function because when I plug in negative 2 to the function, sometimes I'm getting 2, and sometimes I'm down here getting negative 3. I'm getting 2 different outputs for the same input. The big one here is 0. Look at the x value of 0. I've got a point here, I've got a point here, I've got a point here, and I've got a point here. If I plug in 0 into this function, I get 1, 2, 3, 4 different answers. That's like plugging something into your calculator and then getting 4 different answers 4 different times that you do it, which makes it not a function. So really what you can do is make vertical lines. And if you have a vertical line and it passes through the function more than once, it means you're getting more than one answer for an x value. So we're going to say this is not a function. Okay, here we got a table. So back to the tables. We want to look over here to see if there are any of these that are the same, and there are. Negative 8, negative 8, but look at these. Negative 8, 11, negative 8, 11. That's okay. We're getting the same exact output. So negative 8 is giving us 11 here, and negative 8 is still giving us 11. That's consistent. That's predictable. It's giving us the same answer for the same input. And these 3 numbers are all different. So we would say, yes, that is a function. So just because the input shows up more than once doesn't make it a non-function because we had the same output. So if the outputs are the same, that's okay. If the outputs are different, not okay. Okay, last one. If I were to make vertical lines through here, look at each of my vertical lines that I made. They only pass through the function once, which means for that x values, like this would be the x value of negative 3, I'm only getting 1 y value right here. For this x value of negative 2, I'm only getting 1 y value right here. For this x value of 0, I'm only getting 1 y value. For over here, 1 y value. This one, 1 y value. So we would say that's a function because it's consistent and predictable. All right, last question before we get to our learning log. Here I've got a line, and based on this, we're asking ourselves, are all lines functions? Well, looking at this one, it looks like indeed, yes, this is a function because I'm getting 1 point here, that's negative 4, negative 3, I'm getting 1 y value. For -2, I'm getting one y value. For -1, I'm getting y value. For 0, I'm getting one y value. Wow, every single time I'm getting one y value for an x value. So 1, 3 is an answer, 0, 2 is an answer. I'm getting one y value each time. But are all lines function? Can you think of a line that's going to give you the same x value but a different y value? There is one. See if you can come up with it. Some of you might have thought of it. What if you had a vertical line? So here I've got a vertical line. And this vertical line, this point right here is the point 4, 0. This point right here is the point 4, 2. This point right here is the point 4, -4. I've got 3 different points, all with the same input, but with 3 different outputs. That is not working out for us. We can't have different outputs for the same input. So we would say this is not a linear or a vertical line is not a function. So a vertical line is not a function. There we go. All right, so the learning log, this is where you need to, on your notes, write out your response. So I'm looking for sentences here. Describe what it means for a relationship to be a function. Okay, so what is special about a relationship with its inputs and outputs in order to be a function? Now, I don't want just you to give me the exact answer. What I want you to think of is, what does it mean for a graph? How can you tell a graph is going to be a function? How can you tell a table is going to be a function? How can you tell a situation like the soda machine is going to be a function? So kind of talk through those like 3 situations of what's it going to look like for a situation to be a function? What's it going to look like for a table to be a function? What's it going to look like for a graph to be a function? So in those 3 areas, what does it mean if a relationship is a function? All right, that's all we got. Good luck. See you later. Bye-bye.